This is Mr. Martin. This is the video solutions for page 567, number 5. So we're given that the figure is a regular pyramid, and we're also given the midpoints of its lateral edges are joined to form a square. So we know A, B, C, D are midpoints of their respective lateral edges. And then we're given that PR is 10 and that RX is 12. So some other things that we know, since A, B, C, and D are midpoints, we know that each of these lateral edges are going to be 5. And again, since A and B are midpoints, we know that AB is a midsegment of this front face, as are the other sides of that square. So since RX is 12, I know that AB is going to be 6, as is BC, CD, and AD. So for part A, we want to find the lateral area of the whole large pyramid. So we're looking at 4 of these triangles. Okay, so in order to find the area, I'm going to need to find the height, which is the slant height here. This is going to be a right angle. And I know that this is going to be 6 because this also bisects the edge of the base there. So I need to find the slant height here. So I'm going to use the Pythagorean theorem. Actually, it's going to be a 6, 8, 10. So I'm going to call this point here W. So PW is going to be 8 because it's a 3, 4, 5 triple times 2, 6, 8, 10. And now that I have that, I know that the lateral area, it's going to be 4 times the area of one of these triangles. So it's going to be 1/2 times the base, which is 12, times the height, which we figured out was 8. So let's see what we've got there. We've got 2 times 12 times 8. So that gives us 192. So that's for part A. Now what we want to do is we want to find the lateral area of the small pyramid on top. And since the two pyramids are similar, the sides, the corresponding sides are in a ratio of 1 to 2. So their areas would have to be in a ratio of 1 to 4. Really, I could divide this area by 4 to get the lateral area of that, but we'll go ahead and calculate it. Again, it's going to be 4 times the area of a triangle, so it's going to be 1/2. The base of this one is going to be 6. The height of it is going to be half the height of the other one, since the other one's height was 8. This height's going to be 4. So that gives us 312 times 4 is 48. And 48 is in fact 1/4 of 192. So for part C, we want the area of square ABCD. So it has sides of length 6. So the area of the square is going to be 6 times 6, or 36. For this one, we want the area of square RXYZ. So its sides was 12, so its area is going to be 12 times 12, which is 144. And again, these two squares are similar, so the ratio of their areas should be the square of the ratio of any pair of corresponding sides. So it should be 12 squared to 6 squared, which of course you can see it as if we do the ratio of the areas. So it would be 36 to 144, which is going to reduce. So we get 1 to 4, just like we did for the ratio of the lateral areas. All right, and then the last part, what's the area of trapezoid ABXR? So that's this one here. So we know the area of a trapezoid is going to be 1/2 base 1 plus base 2 times height. So that's going to be 1/2. The top base here is 6. The bottom base here is 12. The height is going to be half the height of the whole thing. The whole thing was 8, so that's going to be 4. So we get half times 18 times 4, which is going to be 36, if I did that calculation correct. So if you still have questions, make sure you find me. Write down your questions so you don't forget, and we'll see you next time.